All right, before we start looking how to solve our systems of equations using matrices, we first got to reflect on some definitions that we've done in the past. So for example, we got this definition, multiplicative identity. That just means when I multiply something by 1, I get the same number, right? So a multiplicative identity is using the number 1, okay? And multiplying by 1, just like we talked, it doesn't change the identity of what's being multiplied. So we're going to have, which we've already discussed, a multiplicative identity for matrices as well. And then we also have multiplicative inverses, or multiplicative inverses, however you want to describe it as. So just think an inverse when we multiply is just the reciprocal. But basically you should know that when we take a number times its multiplicative inverse, we get the identity. That's kind of the key that we want to know. Okay, so when we take a number times its inverse, we get an identity. So get that down. So a number times its inverse, we get the identity. Okay, that's what's important when we look at matrices here. So with matrices, understand that the square matrix with 1s in the diagonal and everything else being 0 is called the multiplicative identity. So for example, these ones that we looked at previously. So if I have a 2 by 2, like if I'm trying to solve for like an x and a y, I want this identity right here, 1, 0, 0, 1, right? The 1s are on the diagonal. If I'm looking to solve for 3 variables like x, y, and z, it could be different letters. I got 1s on the diagonal, everything else is 0. Okay, and if it's a 4 by 4, if I'm trying to solve for 4 variables, I need 4 equations, which we'll see here in a bit with our systems. But just know that the 1s are on the diagonal, the main diagonal, okay, and everything else is 0 for the identities, right? So just understand that. Well, matrices have inverses. And what happens is I have a matrix right here, and this is its inverse. So this is this guy's inverse right here. And if I would happen to multiply by its inverse, guess what I get? I get the identity. Just like it is with numbers, right? If I took 2/3 times its inverse, I'd get 1, the identity. Okay, the same thing works with matrices, right? And I could prove this to you. If I just do like the first one, remember I'd take this first row and match it up with this first column. So for this first spot up here, I would take 1 times -2, and I'd add that to 2 times 1.5. Well, what do I get? I get -2 plus 3, which is 1. So it works out. Then if I did it to the next column, I'd get 1 times 1 plus 2 times -0.5. So I get 1 plus -1, which is 0. Okay, so it's going to work out if I went through the whole thing or if I use my calculator to check it. But just know, if I take a matrix times its inverse, I should get the identity matrix. So are these matrices inverses? Well, how would I check? Well, yeah, we would multiply them to see if it would equal 1, 0, 0, 1. So let's go ahead and do that. Let's grab our calculator. Remember, we hit second matrix, and we got to go over to edit in order to enter some in. And it looks like I have a 2 by 2. And I got 3. Okay, and then I'm going to have to enter another matrix. Okay, so we called this one A and we called this one B. So I got to call upon those guys and multiply them. So I get to my home screen first and then pop up my matrix. And I'm going to grab A and I'm going to multiply it to B. There we go. I got the identity, so that works. Yes, these would be inverses. So I would say yes. And I could do it the long way by hand, but hey, we got our calculators. Let's use our calculators. Let's learn how to use those bad boys. Well, there's also a quicker way how to find inverses. So if I'm just checking for the inverse, which I could have done it to this guy. I could take the inverse of this to see if I get that. But let's do it to this. What is the inverse of 3, 7, 2, 5? Okay, well, let's call this matrix, or this matrix, my fault. Let's call it A. So if you put this in the calculator, what I want to do is enter this notation right here for this -1 standing for the inverse. And I'll demonstrate what we mean. So if I edit the matrix A, 5. Okay, so now if we call upon matrix A, there's matrix A, 3, 7, 2, 5, and if I want the inverse, I call upon it, and we actually have an inverse button right here. It's this to the negative first power. Right? It's kind of like the reciprocal button, but it's on our calculator, it's known as the inverse button. Right? 'Cause remember, we have inverses of functions as well. And there's our inverse, 5, -7, -2, 3. So if I check that out, yep, 5, -7, -2, 3. That is correct. So to find the inverse of a matrix, all I got to do is type it in and then hit this inverse button on it, and it should give me the inverse. Okay, and why can we only find the inverse of a square matrix? So for example, if I had like a 2 by 3, so if you look at a 2 by 3 on matrix E, let me see if I can find the inverse of that. So if I grab E and try the inverse, why does that not work? Why can I not find the inverse of something that's not a square matrix? Well, if you think about it, they need to have, remember, a matrix times its inverse has to be one of these identities for it to actually be an inverse. So what do these all end up being? They end up being squares, 3 by 3, 4 by 4, okay, 2 by 2. That's why they can only work with square matrices. So you can't do it with like a 2 by 3 or a 4 by 6. They got to be square matrices. It's going to make it nice and neat. So what does this have to do with systems anyway? Well, I'll show you. It's going to help us on our calculator. So for example, here I got a system of equations, right? Two equations with two variables. And we can write this as a matrix just like this. So I can take my coefficients and write them into a matrix just like this. So this is my first equation, x and the y, second equation, x and the y. And then if I put x, y in a column form like this, it should make sense. Because if I were to multiply these, I would take this row times this column first. So I'd get 3 times x, and then I'd take plus -5 times y, which is this right here, right? 3x and a -5y. So that's why I'm able to write that like that. Okay, so we basically just put a matrix for these guys with just the coefficients, right? The 3, the -5, the 2, and the 1. And then I write in this matrix, this xy, and that's going to equal a matrix of our solutions, this 1 and -2. So I put that down here. Okay, and the reason why we're going to do that is because this. So now what we can do is call one of these A and call one of these B. And let's type them into our calculator. And what we can do is, so now, instead of writing this all out, that's going to be matrix A represented on our calculator. And I'm going to have this, our XY here. And this will be matrix B. So first, let's go type these in. And then I also want to go to matrix B. Oh, edit it. Okay, and so to figure out what to do with these guys, what we want to do is this. Think about our equation we just set up right here. Matrix A times this xy equals matrix B. In order to get the xy by itself, like we're trying to solve for the x and the y, what I have to do is I have to cancel this A. Well, to cancel something on an equation, we always do the inverse of what's being done. So what's the inverse of A? Well, it's multiplying by a -1, right? That's our inverse. And whatever I do to one side, I have to do to the other side. So those cancel, and now right here, our xy would equal b times a -1. So let's think, before I type this in the calculator, does it matter which order? Can I type it in this way, or would I have to type it in with the inverse first? Well, let's think about this. If I did it this way, that would be 1 -2 times a 2 by 2, right? I'd have numbers like that. Well, I would need the same amount in this row to match up with this column. And since there's not two numbers here, there's only one, I cannot do this. So this would not work. So I have to do it this way, because I have to take a 2 by 2 times a 2 by 1. Because what needs to happen is two numbers, right, need to multiply by these two numbers and be added together. So that's why I have to do it this way. Okay, so that's where it gets a little bit tricky. So really, ultimately, what's happening is, when you get a system, all you do is rewrite it as a matrix. Okay, so take the coefficients on your variables, write it as a matrix, and then make another matrix out of your solutions, just like that. Call one of them A, call one of them B, take the inverse of the coefficients, and multiply it by the answers. That's all that's really happening. So let's go ahead and do that. So I did it right here. I typed them all in. I took the inverse of A, and I multiplied it by B. And there we go. There are my solutions. So this would be your x, right, because the x is on top here, and the y would be on bottom. So x would equal negative 0.69. Let's round to the nearest hundredth here. And y would equal negative 0.62. And just remember, we always write answers as an ordered pair for systems. So this would be just like that. There we go. So let's try one with 3 variables. Okay, so let's take a look here. So now I got to think, I'm going to take this and I'm going to make this a 3 by 3 matrix. So I got 4, I got a coefficient of positive 1 and a coefficient of negative 2. And then I got a coefficient of 3. Oh, be careful, right? X's are here, Y's are here, Z's are here. So what's my Y? There is no Y. So I got to put a 0 for a placeholder right there. And then my last coefficient is 5. That's important that we have that. And down at the bottom I got 8 and 3 and negative 1 right there. Okay, so there's my matrix, and then I'm going to multiply that by, well, I got an X, I got a Y, and I got a Z now. And that's going to equal our 10, 14, 23. So remember, all I got to do is I got to type this guy in, and type this guy in, and take the inverse of our coefficients, and multiply it by our answers. So let's go ahead and do that. So now we got a 3 by 3. So that one's good. And now our answers are going to be a 3 by 1. We go to our home screen, and then we take our inverse of A and multiply it by B. 3, 0, and 1. So there we go. So x equals 3, y equals 0, and z equals 1. And if I wanted to write it as an ordered pair, that would be 3 things. So I had 3, 0, 1. This would probably be sufficient when we have 3 variables, since we haven't got into our graphs that have 3 variables. So on and so forth. So basically just writing a matrix for the coefficients, writing a matrix for the solutions, then multiplying the inverse of the coefficient matrix to the other one. And if you get a story problem, the biggest thing is to just write your equations first of all and then be able to write a matrix. Let's just get this set up. We won't actually solve it, but I got 1 soda and 1 single burger costs $2.28. So let's give some variables. So let's go x for the cost of soda. And next go y for the cost of a single burger. And then we also have what? Double burgers. So I got a double burger, so we'll call that z, and that'll be the cost of a double burger. So right away I got 1 soda and 1 single equals $2.28. And then I got 2 single burgers, a soda, and 1 double. So soda, 2 singles, 1 double, and that equals $5.96. I could use different variables. I don't have to use x, y, and z, I guess, but we'll just use that in this case. And then lastly, I got 3 sodas and 4 singles and 5 doubles. So 5z. And that's 2008. So there we go. So if I wanted to solve this, I'd have to write 2 matrices. So one matrix would be with my coefficients here. So that would be what? 1 for x, 1 for y, right? Because there's nothing in front, so it's a 1, and a 0 for z since it's not there. Then I'd have a 1 for x, a 2 for y, and a 1 for z. 1, 2, 1. And I'd have a 3 for x, a 4 for y, and a 5 for z. 3, 4, and a 5. And I'd end up doing the inverse of that, right? And I would multiply it by my answers here, the matrix of the answer. So it'd be 228 and 596 and 20.08. So I'd have to get those typed into the calculator. Okay, I'm sure you could finish that out if you'd like, but just know that you can apply this to story problems as well.